we're going to be going over nomenclature, which is just what we call naming things in chemistry. So giving chemicals their chemical name and basically figuring out the formula from that name as well. So the first thing we're going to start with are molecular compounds. So these are pure molecules, which means they are made of two nonmetals. So any two nonmetals are bonded together covalently. So they have a covalent bond. Like I said, usually this is the bond you will see with nonmetals. These are the names that you see that have Greek prefixes in them. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. And there are more that go above 10, but rarely will you see them. So each of those, that's 1 through 10, just in order for those Greek subscripts, or prefixes rather, and those prefixes tell you the subscript that will be after that chemical element in the chemical formula. So if the first element that is named or used has only one atom in a molecule, the prefix mono is dropped, so we don't use it. But other than that, everything is going to have a prefix in front of it. The second element is always going to end in "ide." In order to determine which element goes first, generally the less electronegative element is written first. And electronegativity is a trend that we should have talked about in Introduction to Chemistry, so your first chemistry class. If you need to review, ptable.com is really good at that. You can select options, basically like a heat map, that shows you how electronegative the elements are relative to one another. So you can review that trend using ptable.com. There are some exceptions though. So for example, carbon is always first in a formula, and hydrogen is after nitrogen in a formula such as NH3. The order of common nonmetals typically is carbon first, phosphorus, nitrogen, hydrogen, sulfur, iodine, bromide, chlorine, oxygen, fluorine. So obviously that doesn't list all of the elements, but those are really common elements that you see in molecular compounds. So that is the priority order that you will see when listing the chemical formula for those. But generally, you will get used to seeing those anyway, so you don't really have to memorize it or anything, but when in doubt, you can reference that order if you need to. If we have an element that begins with a vowel, like usually oxygen, we usually drop the A or O that comes at the end of the prefix. That way we don't have a double vowel. So we say tetroxide versus tetraoxide. So we drop that A before the O, and that just makes it easier to say. That is the only reason that is. So here are some examples. They first only have one carbon and two oxygen. So remember, if the first element only has one, we drop the prefix mono. So that should be carbon dioxide. The second one, the first element also has only one, so that's phosphorus. And then we have 5 chlorine, so that would be pentachloride. The third one, we have N2O3. So that would be dinitrogen trioxide. And then for the last two, we are given a name, and we want to give the chemical formula. So sulfur tetroxide, there's no mono in front of sulfur, but we know it's mono because it's the first element and it has no prefix. So that would be SO4, because tetra or tet means 4. And then the last one is heptanitrogen dibromide. So hepta means 7, di means 2, so that should be N7Br2. Okay, so those is the review for just molecular compounds. The second type of compound we're going to talk about is ionic compounds. These do not have prefixes, but that doesn't mean that their subscripts are just one. So for ionic compounds, they never have a covalent bond, they have an ionic bond, which means that we have two atoms that have essentially become ions, hence ionic, and they are attracted to each other because they have opposite charges. To know the subscripts here, we have to pay attention to charges to basically make sure that we have a balanced, non-charged, what we call formula unit, which is a molecule in ion world. So ionic compounds are always made up of a metal and a nonmetal, or a metal and nonmetal and a polyatomic ion, or two polyatomic ions. So there is a list of polyatomic ions that you are to remember, and that is on the summer review sheet. Ionic compounds do not have prefixes because their relative number is determined using the charge of the elements that they take on when they form an ion. And that is, again, part of your summer work to memorize those charges. We always have the name of the metal just as it appears on the periodic table, followed by the name of a nonmetal that ends in "ide." If we have a transition metal, that is the metals that come in the center block of the periodic table, there's going to be a Roman numeral that tells us the charge of that metal because transition metals have variable charges. Sometimes one element might have more than one possible charge as well. If you see silver, usually we don't have a Roman numeral because the most common ion of silver, and usually the only one that we ever see, is silver 1. So usually if silver is in there, it's just a charge of 1, but you won't necessarily see a Roman numeral. So here we have some examples. The first, we are given names. So magnesium fluoride. If I look on the periodic table, magnesium is a group 2 metal, so it's going to have a charge of Mg. Of course, my marker doesn't work. Let me grab another one. So magnesium is a group 2 metal, so that means it's going to have a +2 charge. So we have Mg2+, and then we have fluoride, which is in the second to last group, so it has a -1 charge. To balance these, you can consider, well, how many, like we have a 2+ here, how many fluorine do we need to balance that out to get a net charge of 0? But I always just kind of use the crisscross method because it's just the easiest to remember. So if we take the charges here and crisscross them, basically make an X there, we have a 1 that comes down next to magnesium. Never have to show that. And we have a 2 next to fluorine. So we have MgF2. That would be the chemical formula for magnesium fluoride. For silver sulfide, silver, again, is usually +1. Sulfide is in group 16, so it has a -2 charge. So to balance those charges, we should have Ag2S. For calcium nitride, both of these have a charge that is, neither one has a charge of 1, so each one is going to have a subscript. Calcium has a 2+ charge. Nitrogen has a -3 charge. To balance those, we would have Ca3N2 if you just crisscross their charges. Copper 2 iodide, we have a 2+ and a 1-, so it would be CuI2. For iron 3 phosphide, we have Fe3+, and phosphide would be P3-, so those balance one another out. So if you were to do the crisscross method for that, we would have Fe3+ and P3-. If you crisscross, you get Fe3P3. For ionic compounds, if you have 2 that have the same subscript, you just reduce them to 1. So we have FeP for that chemical formula. Okay. Then NaCl is sodium chloride, so name of the metal, sodium, and then name of the nonmetal ending in ide. We have potassium sulfide, and we have aluminum fluoride. So sodium, potassium, and aluminum, none of those are transition metals, so we do not need any Roman numerals for those names. The biggest mistake that comes from this is usually with the transition metals, when you see that Roman numeral, the easiest mistake to make is to say that I have 2 copper. But what it's really saying is that I have a copper with a 2 charge, okay? So the Roman numeral describes the charge, not the number of atoms that you would have in that formula unit. And there are your answers written out for you. The last one I want to talk about is acids. And there's 2 types of acids that we're going to talk about. So we have binary and ternary acids. Bi means 2. So binary acids are molecular compounds, usually, that have H as the first element. And ternary acids are polyatomic ions that are bound to an H to form an acid. So the reason a lot of acids, not all acids, have this H in front of them is because acids are usually, or can be described as proton donors. So remember with the atomic model, if you're looking at an atom of hydrogen, we have 1 proton surrounded by a 1 electron, and there's probably a neutron in there somewhere as well. But here, if we just remove the electron and the neutron, what we get is an H plus ion. So that is a proton. An H plus ion is a proton because in the atomic model, if we have an H plus ion, all it is a proton. And maybe a neutron in there, depending on what isotope of hydrogen you have, but you get the idea. So for binary acids, they will always be named by hydroblankic acid, where the blank is filled with the name of the root of the element bonded to hydrogen. For the chemical formula, the subscripts are determined just like they would be for an ionic compound. So H always has a +1 charge. The other nonmetals will form a various minus charge that we will use to balance those out. So if you have something with a -2 charge bonded to H, we're going to have 2 H's to balance out that -2 charge in the acid formula. So here we have examples. Spoiler alert, forgot to edit my slide. The first one we have HBr, and that's hydrobromic acid. Second, HCl is hydrochloric acid. The third one, H2S, is hydrosulfuric acid. So sulfur, when it forms an ion, has a -2 charge. So we need 2 of those H's to balance it out. Then we have HI, hydroiodic acid, and HF, hydrofluoric acid. Okay, so the key to knowing when you have a binary acid is that hydro out in front. With ternary acids, we do not have that prefix. So we have blank-ic acid for polyatomic ions that end with the suffix -ate, and blank-us acid for polyatomic ions with the suffix -ite. And to remember those ending changes, I always remember I ate so much I got sick. Ate goes to ic. And then that mosquito bite is ginormous, so ite goes to us. Again, hydro is never a prefix for ternary acids. Hydro will indicate a binary acid. And the biggest mistake I usually see is with sulfuric acid. Sulfuric acid is a ternary acid, but so many times people want to put H2S because they see sulfur and they think, oh, it's just sulfur and hydrogen. But that's not true. Hydrosulfuric acid is H2S. So here we have some examples. So the first couple, I'm giving you the name. So us came from ite. So that's going to be H with a sulfite ion. Ic comes from ate. So that's going to be H with a carbonate ion. Again, us comes from ite. So that's going to be nitrite and H. For HNO3, NO3 minus is nitrate. So that's going to be nitric acid. SO4 is sulfate, so it's going to be sulfuric acid. And PO4 is phosphate, so it's going to be phosphoric, however you want to say it, acid. Okay, so there are your answers for your ternary acid naming. Okay, so that's a little review on nomenclature.